All right, guys, hopefully everybody felt good about the Chapter 7 test. We are going to cruise right on into Lesson 8.1, which is adding and subtracting polynomials. What we're going to learn to do today is we're going to classify polynomials and monomials. We're going to add and subtract. And so one of the first things that we're going to look at is just examples of what they call a monomial. A monomial, I always think of the word one, meaning we've got one term. If you notice, all of these that I'm boxing out are monomials. And in each monomial, I have no adding or subtracting between them. That means it's a monomial. And the first thing we're going to need to do with a monomial is we're going to need to find the degree of a monomial. And to find the degree of a monomial, all it is the sum of the exponents of its variables. Variables being the key word. So let's take a look here at problem 1. Now I have one variable. My variable is x. So the exponent on that x, guys, is a 1. That means the degree here is 1. If I cruise to part B, I've got two variables. I've got x and y. And if I think about the rule, the degree is the sum of the exponents of its variables. So I need to, for this guy, I need to add 3 plus 2 and figure out that the degree is 5. Now, if we look at part C, last one, guys, there are no variables. And so if there's no variables, it's called a constant, meaning it's just a number, no variable. So this has a degree of 0. So for these guys, if we were together in class, I would have you guys try these on your own. But since we're just doing a video lesson, we will do these together. So taking a look at part A, I've got to add the sum of the exponents of the variables. This would be x to the power of 1, y to the power of 1. So my degree is going to be 1 plus 1 or 2. On part B, degree is the sum of the exponents of the variables. I can see y has an exponent of 4, but we have to remember that z has an exponent of 1. And so the degree is going to be 4 plus 1 or 5. When I take a look at part C, this is again a constant, meaning it's just a number. There is no variable. And on something like this, the degree is just 0. Okay? All right, so the next thing we're going to do, guys, is we're going to work on adding and subtracting monomials. And so basically, all we want to do is add and subtract what we call like terms. Now, in problem 2, I can see that 3x squared and 5x squared are what we call like terms. They have the same variable, they both have an x, and they have the same exponent. They're both x squared. So when you go to combine them, all you're adding is the number in the front. 3 plus 5, so you get 8, and you always keep the variable and the exponent the same, x squared. Over here, guys, in part B, we've got 4x cubed y minus x cubed y. Again, these are like terms. They have the same variable. They have the same exponent. We have to remember that in front of the second monomial, there's a 1. So 4 minus 1, I get 3x cubed y. Taking a look down here, we're going to add and subtract. So in this first one, it wants the sum. I'm going to add negative 6x to the 4th plus 11x to the 4th. These guys are like terms, x to the 4th, x to the 4th. So all I'm going to do is add the coefficients. Negative 6 and 11 adds up to 5, and we keep x to the 4th. Over here, I'm going to do the subtraction. What is the difference? Now look again at the variables and the exponents. X squared y to the 4th, x squared y to the 4th. Those are like terms. So all I'm going to combine is the number in the front. 2 minus 7, I end up getting negative 5x squared y to the fourth. All right, guys, so the next thing that we're going to talk about is something that they call a polynomial. And all a polynomial is a bunch of monomials put together with addition and subtraction. If you take a look, this is a monomial, this is a monomial, monomial, monomial. But when I put them all together, separated by either an addition or a subtraction sign, that makes this a polynomial, many terms. Okay, now each polynomial has a degree. The degree is just the exponent. So in the first term, the exponent is a 4. The next term, the exponent is a 2. The next term, this really has a 1. And then this guy doesn't really have an exponent because it's not, well, it has an exponent, but it's not a variable. All right, now the next thing that we're going to talk about is something called standard form. We always need to express every answer in what they call standard form, and that just means that you're arranging it from the highest exponent, 4, down to the lowest exponent, and we always end with just the plain number at the end, 1. Okay, so if we take a look at a couple of names and things like that, this is a little bit of a naming chart. So every polynomial is going to have a first name and a last name. Now, the name based on the degree is going to be the first name, and the name based on the number of terms is going to be the polynomial's last name. Just like us, we have a first and a last name. So you can see if we have a degree of 0, we call it a constant. That would just be like this, a plain number. If you have a degree of 1, that's linear. This guy right here has an exponent of 1. If you have a degree of 2, it's quadratic. A degree of 3, it's cubic. And then anything past 3 would just be 4th degree. If I had something like 7x to the 5th plus 2x, I would say that that's a 5th degree, so on and so forth. That's all the first name. Now the last name is based on how many terms you have. If you have 1 term, it's a monomial. 2 terms, a binomial. 3, trinomial. And then if you have 4 or more, we call that a polynomial. So let's take a look at problem 3. We have 2 directions. Write each polynomial in standard form, and then we need to name the polynomial. So standard form means biggest exponent first. I've got 3x to the 1 plus 4x squared. I want 4x squared to come first because that has a higher exponent, and then 3x to come at the end. So now that is in standard form. And as far as the name goes, the first name is the degree. For a polynomial, the degree is just the biggest exponent. So my degree is a 2. If I look up at my chart really quick, a degree of a 2 is called quadratic. So this little guy's first name is a quadratic. And then the last name is the number of terms, or the number of things we're adding together. I have 2 terms. So again, if I look up at the chart, 2 terms is called a binomial. So guys, this is going to be called a quadratic binomial. Let's take a look at part B. So first I have to get this into standard form. Biggest exponent first, down to the littlest. I'm going to write in an exponent of 1 when it's not there. So I've got 5x to the third. I'm going to cross them out as I go. Positive 4x, positive 7x, and then negative 1. A plain number always ends at the, we always put that at the end, rather. All right, so now that we have that, one of the things that you may notice is we have some like terms. If you have like terms, you must combine them. So let's go ahead and do that. I'm going to bring my 5x cubed down, but I can add 4x and 7x to get 11x. Now that's in standard form, and we just need to name it. So the degree is going to be the largest exponent, which is a 3. If I look up at my chart, a degree of 3 is called cubic. So this guy is a cubic. The number of terms is the last name. I've got 1, I've got 2, I've got 3. So if I look at the number of terms, 3, that's called a trinomial. Guys, this chart in your notes is something that you definitely will come back to reference. So yeah. One more that we're going to try. We're going to take a look at this guy. We've got 2x minus 3 plus 8x squared. So the first thing I want to do is get it into standard form. I'm going to write that exponent of 1 in. My biggest exponent is going to be 8x squared. Next will be that positive 2x in the front. Plain number at the end always. So now we've gotten that into standard form. And from here, guys, we're going to name it. So the first name is the degree. The degree is the biggest exponent. The degree is a 2. We call that a quadratic, and you can look back at the chart if you're not sure. And then the last name is based on the number of terms. I've got 1, I've got 2, I've got 3 terms. That's called a trinomial. Quadratic trinomial. All right, so our last example is going to be subtracting polynomials. And so when I go through to subtract, one of the things that I'll always do is whatever is in the first set of parentheses, I'm going to keep exactly the same. So I'm just going to rewrite it without the parentheses. Now, the next set of parentheses has a negative in the front. So I have to be sure to distribute that negative to everything in the second set of parentheses, which is going to mean everything's going to change signs. So it's going to be a negative 7x to the third, a negative 5x squared, and a positive 12. Now we're going to combine like terms, or CLT. I just wrote that off to the side. So I have an x cubed or a 1x cubed. That can combine with negative 7x cubed. So I'll give negative 6x to the third. I have a negative 3x squared. That can combine with a negative 5x squared. So I get negative 8x squared. Now, I see that I have this 5x, but there's no other plain x term for that to join with, so we'll just bring that down. Same thing with the 12. There's no other number for that to join with, so we're just going to bring that down. This is in standard form. We have to make sure that all of our answers are in standard form. Biggest exponent down to the littlest exponent. All right, guys, so we're going to take a look at one more. Again, this is a subtracting, so I'm going to keep everything in the first set of parentheses exactly the same. Because I'm distributing this negative, that means I have to switch all of these signs. So negative 4m squared, negative m, and positive 12. Everything in this second set of parentheses just switches, opposite signs. Now we'll combine like terms. So I'm starting with a negative 4m to the third. As I look down at my other terms, there's no other m to the thirds. So that's just going to come down by itself. I can see that I have a negative m and a negative m. Those will go together. Remember, there's really a 1 in the front. So negative 1m and negative 1m is negative 2m. So I'm going to cross those out as I use them. I've got a positive 9 and a positive 12. Those two can go together, so I get positive 21. Again, I'll cross those out. And finally, guys, we have a negative 4m squared. There's nothing for that to join with, so I'll just bring it down. So at this point, we have done our subtraction, but I want to make sure that my answer is written in standard form. And so I need to rearrange it. Biggest exponent down to the littlest. Negative 4m to the third, that'll be the first one. But now I've got to put this, the negative 4m squared. That needs to come next. Negative 2m. And finally, the plain number, or the constant, the positive 21. Now that answer is in standard form. All right, guys, so we are done for this. Today, what I'm going to have you guys do is IXL Z1 and Z4. I want you to get both of these to 60%. You will, when you are all done, submit, a screenshot of your score. Now your screenshot needs to include your name, the skill name, and your score.